Welcome to Algebra 2-2, Unit 11, study guide for the final exam. Again, I want you to focus on these multiple choice problems, eliminating the wrong answer, and showing the work as to why, justifying why you say what is right is right. This is Unit 11 again. So here we go. First problem. We can see we're adding and subtracting radicals, so we need to make sure that we have like terms here. Okay? Make sure that everybody's out of prison. The 4 is a perfect square. It can come out as 2. And if we have 7 x's under there, they come out 2 at a time. Expand that out if you need to see it. We'd have 3 x's. That would be 6 of them wiped out. There'd still be an x left in there. If there's 5 y's, 4 would get wiped out, 2 come out, and 1's left in there. So that would become radical xy. Now here we have 3 x's, so 1 more set can be wiped out and 1 brought out, so we have plus 9x cubed. Here we have 5 y's, just like there, so we'd have a y squared and a y left in there. There was an x left in there, so we have like terms right there. See if the same thing happens here. We can get 4 of those wiped out, and that'd bring 2 pairs out here. So it would be a minus 5x cubed. And we have 3 there, so 2 would wipe out. Another one would be out there. So we do have all like terms here. Factor out the x cubed, y squared, radical xy, and simply manipulate your integers. 2 plus 9 would be 11, minus 5 would be 6. So there's our answer. This one is the correct answer. This one, the only thing wrong with it was 8. 2 plus 9 is 11. Minus 5 is 6, so we make sure that that's correct. This one, we've got exponents off there, and exponents off here. Now the numbers are as well, but I'm just looking at the obvious there. Okay, which of the following expressions simplifies x squared and radical y? Well, we need to take these and make sure that they're equal to this, but I also want to look at our other option. We can have x squared radical y, or we could have y 2 times y to the 1/2. What do we do when we are multiplying terms with like bases? We add their exponents. So that would be y 2.5. That's one possible answer. This is another. When we're here, we've got y to the 7/2 over y to the 5/2. When we're dividing, we subtract, so it's 7/2 minus 5/2. That would equal 2/2. That's y to the 2/2, not, well, let's make that into an improper fraction. That would be y to the 5/2. It's not the same. So which of the following expressions is the same? So that one's out. On this one, we would distribute in. We get 4 squared. Multiply this one. You'd wipe out the bottom, so it's x cubed. Multiply that. That's y to the 2/4, or 1/2, over 2 to the 4th. 4 times that 3/4, the 4's would wipe out, would have x cubed. And we have a negative 4/2, which reduces to 2 over 1. So our x cubes can cancel. 4 squared is 16, and 2 to the 4th is 16, so those can cancel. So now we have a negative exponent. We bring it up to the top. We have y2 times y the 1/2. That would be the y 5/2. Now I'm not satisfied that that's definitely my answer because we did a lot of manipulating there, so I just make sure. Here we have 1/2 and 3/2. If we subtract those, we would have 2/2. 2 over 2 is 1, so that's going to be 4/3, y to the 4/3. So I know that one's out. This one, we have 9 square root of 9, which would be 3, over 3, those wipe out. X to the 7/2, y to the 2/2, x to the 1/2, y to the 1/2. Now we subtract and we get x to the 6/2 or x cubed, and we get y to the 1/2. That's not at all what we were asked, which was y to the 5/2. So that one's out. If you are not feeling real comfortable with fractional exponents, you definitely need to spend time working problems out of Unit 11. Okay, now we're going to subtract these functions. So 5x squared minus the 3x squared, and 6x minus a negative 5x, and negative 4 minus a 24. So to subtract, we need to change all these signs and then add. The other thing that we're asked to do is to add them. Since we don't have to do any manipulating, I'd like to add first and see if we can eliminate any possible wrong answers. So let's just add them. We'd have 8x squared. Remember, you only add your exponents if you're multiplying. 6x minus 5x would be positive 1x. Positive 24 and a negative 4 would be a positive 20. Okay, let's just look for our added. That one's correct. Ooh, this one's wrong. So that one's out without having to subtract. This one is correct, so we're going to have to subtract. And this one is correct. Okay, so now we subtract. We go 5x squared plus 6x minus 4. We want to subtract, put the big subtract out here. Even though I know you're saying we don't subtract in algebra, you're right, but we need to put it there until we get this set up. 3x squared minus 5x plus 24. Now instead of subtracting, we add the opposites. So we switch that to add, switch all of their signs. We have 5x squared minus 3x squared would be 2x squared. Let's look at our options. That's a negative 2x squared. There's no way that's going to be a negative. So we can eliminate there. These both are still correct. The difference here is the 1x or the 11x, so we'll know on this one. 6x plus 5x, 11x. This guy wins. Nope, that guy was already wiped out for the other one. Let's find it right here. Okay, so 11. That's why I say eliminate clearly why you've canceled them out. There we have the 11x. That's a 1x, so we know this is the real answer. Okay, sorry, I went a little bit off camera. Hopefully you have your study guide out so you're watching it. Okay, I want to find the g of h of x. Remember what that means. That means you're looking at this function, g of x, which equals 5x. And you're saying, I want the h of x to go in place of the x in this function. H of x is equal to 3x plus 8. So in other words, we need to put that in place of that x. 3x plus 8. What would you do? Distribute. You'd get 15x plus 40 for g of h of x. So let's see if we can eliminate g of h of x. 40 minus 15x, there's no minus 15. That's wrong. G h of x, 15x plus 40, that's good. 15x squared, well, let's double check. No, we placed this in place of the x there, so it isn't an x squared. That one's out, and that one's out. So we already know it's that option. Make sure to eliminate. Find the inverse of this function. Now you have 4 different ways that I showed you in class. You can verify something's an inverse, but there's only one way that we really figured out was the easiest way to find them, and that is if we switch this to being y. And remember, inverse means that we flip our x and our y. So we have x equals negative 7y plus 6, get this y alone, minus 6 from each side. So we have x minus 6 equals negative 7y, divide by negative 7, divide by negative 7. Now I look around here, and I can see that I've got 2 answers, but they both have a positive 7. So I need to distribute this negative out to the front. And bring that out to the front, I now see, well, they don't even give me an option of having a negative to the front. I have to bring this clear up into this. So in order to distribute it up here, I would take negative times x would be a negative x, negative times negative 6 would be a positive 6, over 7. So negative x, positive 6. There we go. And you could always graph these to make sure that they're inverses. You can always grab graph paper and scratch paper. Or you could do the function of the inverse and the other function, the inverse, and make sure that they equal x. Look in your notes. Find the inverse function of g of x equals x squared plus 5 over the domain x is greater than 0. Okay, this is why we have to list this, is we're finding the inverse, and remember that the inverse is going to end up being a square root, and that's the one where I said we have some funky limitations that we have to look at when we're doing the inverse. So let's go ahead and find the inverse, switch that to y, x squared plus 5. Now we swap our x and our y. So we get x equals y squared plus 5. Subtract 5 from each side. X minus 5 equals y squared. Now to get that y alone, we take the square root and square root. So we get square root x minus 5 equals, that one cancels, y. Okay. That would be our option. What's wrong with this one? It doesn't go over the 5. There's the problem. Look closely at them. This one's still got a squared. It doesn't even have the square root. So all of it's obviously out. This one has your y underneath there. So that one's out for the y there. Okay. Next problem, it says solve. This is where you draw your line, circle your creepy dude, go up your PIMDAs. Outside of the restriction, we have a minus 10. We would add 10 there. Wipes out. We have square root 5x plus 9 equals 22. Now we've added and subtracted. There's nothing to be multiplied or divided out here. We're up at exponents. We have to get rid of the square root. To get rid of square root, we actually need to square it. And what we do on one side, we do on the other. We're squaring that side. Put that in a calculator. This will cancel that, so we have 5x plus 9 equals, and if you put it in a calculator, you would get 484. Now, we look at this. There's our creepy dude. We want to subtract, get rid of the 9 first. Going up your PIMDAs again. So we have 5x equals 4, 7, 5. Divide by 5 on each side. X equals 95. Right there. Now another option on those that you actually could do is you could plug in the value into x and see which one's true. But I'd like you to show the math. I'd really like to see all this work. I won't give you full credit unless you do show all the math. But plugging it in is better than not doing it. Okay, solve on this one. We end up with -7 out there. We divide each side by -7. That cancels. We get square root of 8x plus 3 equals -2. Now remember, your square root on the real graph is graphed in the positive realm on the parent function. Actually, I should scoot it over there. But it's the positive realm. That's because, remember from Algebra 2:1, we get into imaginary numbers when we have a radical. Actually, no, we get into, oh, I'm totally wrong. It's imaginary numbers if the negative's on the inside of this, but we really can't do a radical in the positive realm. We're up here in the positive, so that's no real solution. Okay, whew, getting tired. Which of the following would not produce the same graph as 256 to the x? All you need to do here is ask yourself, is 2 to the 8th equal to 256? Grab a calculator, punch in 2 raised to the 8th equals 256. So we know that that one is equal to 256 x. 4 to the 4x is 4 to the 4th equal to 256, because they both have the x there. 4 raised to the 4th equals 256. Is 8 to the 3rd equal to 256 to the x? So we just look at 8 to the 3rd. 8 raised to the 3rd equals 512. That's the one that's out. Because it says which one will not produce. Let's double check. 16 squared. Is it 256? It is. So we know this one is equal. Okay. This should be about our last problem on this review. When evaluating the function, f of x equals -2 to the x plus 3. Oh, this is an exponential function. Let's just go ahead and graph it for a second. That might help us, because it's talking about what the y value always is. It'll help to graph it and be able to look at that. So our parent function goes through here, and it would be a growth. It would be getting bigger by 2 each time. It would be roughly like that. Now the movement that we did, we flipped it over the x-axis, so now it comes down this way. But then in addition, we moved it up to positive 3. So here's 1, 2, oops, I'm sorry. There's 1, 2, 3. So we go 1, 2, 3. That's our vertex. So our 0, that's our asymptote, is now right up here, just above it. I have to ask, what would that be? If you remember, that would be the limit on your range, and your range limit is your k value. So the y will come ever so close to the 3, but it can't equal 3. Now, it can go down this way all that it wants. It can come up this way, but it can't ever cross that 3. So let's look at what it's saying. The value of y is always negative. Well, it's not always negative. These are positives, aren't they? So that one wouldn't be true. The value of y is always positive. Well, that's not true because down here's negative. Sorry, my pen's having trouble. The value of y is always greater than 3. Nope, it's not up above 3. The value of y is always less than 3. There we go. That's my asymptote. It's staying below it. That's the one that I want. That's the end of the Unit 11. You only have one more to study for the finals. This Unit 11 will be on the last day of finals week. Thank you.